All right, so we're going to keep talking about parallel and perpendicular lines, but now we're going to very specifically look at the slope of parallel and perpendicular lines because they're related to each other, and we can actually write equations using these concepts. So two non-vertical lines are parallel, meaning that they do not cross and they're the same distance apart, if and only if they have the same slope. So hopefully that makes sense. If I have two lines going like this, they're going to be going up at the same rate. So their slope needs to be exactly the same. If their slope was different, then they eventually would cross somewhere, right? So we need them to have the exact same slope so they never ever cross each other, okay? So the perpendicular, we have two non-vertical lines are perpendicular. Perpendicular if and only if the product of their slopes is -1. So we also call this the negative reciprocal. And so that means if I have a slope A over B, then I'm going to switch it B over A, and I'm also going to change it from either positive to negative, negative, positive. I'm basically multiplying by -1. So it goes from A over B to negative B over A. So I just flip it over, I flip the fraction, and I flip the sign. And with this one, I like to do one in class where I have the two parallel lines where you can see they're side by side, they have the exact same slope. Well, to be perpendicular, I'm going to completely flip that line like this. So now I was going up at a certain rate, but now I'm going to be going down. So I flipped over rise and run. So I was going up and over, but now my up is going to be my over, and my over is going to be my kind of down. I know that sounds funny, but it's flipping spots. I'm literally kind of rotating that a little bit. It's just it completely flips the line kind of over as far as slope goes. All right, let's get that out of the way. So now we can apply this down here. So it says finding the slope of a line parallel and perpendicular to a given line in slope-intercept form. So here we have y equals 9x minus 5. And they want to know what's the slope of a line that's parallel to it and what's the slope of a line perpendicular to it. So we're just identifying the slope. We're not writing the whole equation yet. So remember, this is y equals mx plus b. This is our slope-intercept form. And so m is our slope. So right away, I already know what the slope of this line is. It's 9, which would really be 9 over 1 if we were graphing it. But since we're just identifying the number, it's just 9. So if it's a parallel line, it needs to have the exact same slope. So the slope is going to be 9. If it's perpendicular, now I need to take that slope, which would be 9 over 1, and I need to flip it over. So it becomes 1 over 9. And it was positive, now it's negative. Because remember, I'm taking that slope of 9, which means I'm going up 9 and over 1, like this. I'm literally going to rotate it to make it perpendicular. So now I'm going to be going 9 and 1, like that. So it completely changes that slope. So it flips it over. So I end up with -1 over 9. All right, so now we're going to apply this to actually write an equation. These ones are kind of nice because they always give us the exact same point to work with, which is really nice. Once we write one equation, we just have to change it a tiny bit for the second one. So find the equation of the line that is perpendicular to this line and passes through the point -3, -2. So we're given a line. And then we need to find an equation of a line perpendicular to it. So in order to do that, I need to know what the slope of this original line is. Well, this is y equals mx plus b, so I just need to know what is the m. That's my slope. Okay, so I already know what the slope is. And we need to decide which formula we're going to use. Are we going to use slope-intercept form, which is y equals mx plus b? And in this one, I need a y-intercept and a slope. Or are we going to use point-slope form? And in this one, I need to know what the slope is and a point. Well, I'm given the slope and a point. So the easiest equation to use would be point slope, because they're not specifying which type of equation. It says find the equation. They're not asking or telling me which form it has to be in. So for a perpendicular line, I'm going to use point slope. And so for this one, all I have to do is plug the three pieces in. Remember, y minus equals x minus, like this. These pieces are going to stay exactly the way they are in this equation. We're going to plug in y1, x1, and m. Okay, so we have x and we have y here. So y1 is -2. I'm not going to write y minus -2 like this. It's actually going to change to a +2. So whenever I have a minus negative, it changes to a plus. And then m is the slope that we just identified, which is -2/3. Now, one thing we do need to be careful about, since it's perpendicular, I need to take that 2/3 negative and I need to flip it over. So it's going to be 3/2, and it was negative, now it's positive. So it's going to be 3/2 times x minus x1. So it's minus x minus -3, which is +3. So now I want to do the same thing for parallel, because they're asking for two things here. I need two equations. And if you know how to copy and paste, it makes it super easy. I would copy this formula, because you're literally going to change one piece of it for the parallel line. So you're going to have y minus equals x minus, like this. All right, so we still have the same point, right? It's exactly the same point, x and y. It's -3 and -2. So this +2 and this +3 are still the same. Those have not changed. The only thing that's going to change from this equation to this equation is that slope. We need to go back to the same slope that we started with, because it's parallel to that line. So I'm just going to go -2/3, and I'm done. So that's what I meant by it's kind of nice when they give us that same point. It's the exact same equation with just a tiny little tweak. So pay attention, though. Sometimes they'll start with parallel instead of perpendicular, so pay attention. Make sure you read this and you're paying attention to which one you're typing it into. Otherwise, of course, you'll get it marked wrong if it's, if you typed the parallel equation into the perpendicular answer spot. So just be careful there. But all right. So that's how you use the slope and parallel properties to write an equation for lines that are parallel and perpendicular to a given line. So go ahead and go on, Alex, and give that a try.